Hi everyone, Mr. Nelville here to walk us through the next couple steps. Today's lesson is just a review lesson of a lot of the topics that we've already covered. We're going to have an opportunity now to test out some of those formulas in a different context. Right now, you're doing the first step by watching this video. Make sure you're following along on the Google Sheet as well. We're going to do a couple reminders of different formulas that we've learned about. The first one is the random formula. Random will give you a random number between 0 and 1. So this will be a decimal, and this is perfect for probabilities, because probabilities will always be a value between 0 and 1. So here in cell C8, I'm going to write equals, there we go, equals rand, open, close parentheses. That's it. And the second you do that, you get a new number. All right. What about rand between? Rand between is where we can write equals rand between. And then when we open parentheses, we see here, it'll be a uniformly random integer between two values. So in those two values, this example says we want between 1 and 50. So we're going to do rand between 1, 50. And one thing I want to show you is in column H, I've made these cells equal rand between 0 and 5. And we're going to use that to help us out here. In cell F8, we're going to test out the count formula. The count formula outputs how many cells have numbers in them in a range that we specify. And so this one, it says how many in the list in column H. So we're going to do equals count, open parentheses, and we're just going to say from this value to this value, from this cell to this cell. How many are there? There are 7 numbers. Count ifs tells us how many in a certain list meet a specific criteria that we're setting. So in this case, the question's asking us to do how many in the column H list have 1 in it. So we're going to write equal count ifs. And again, if you're ever confused, what's really nice is this thing will pop up, or you'll hit a little question mark and this thing will pop up that tells you what needs to go in each place. And it'll give you an example. So here we want this list, and we want to say, is it equal to 1? And so we have to do quotation mark equal 1, close quotation mark. Then we close it. And right here, you'll see that numbers change and it's 0, because remember, random lists will keep calculating random values. And right now, there's no 1 in this list, so that's a 0. The final thing that we learned about was an if statement. And the if statement tells us that if we meet a certain criteria, it'll give us one output. And if we don't meet that criteria, we'll get another output. So let's test it out. Equals if. And what cell do we care about? It says if there are at least 2 ones, say yay. Well, where are we counting the ones? We were counting the ones in that previous cell in F11. So if F11 E is greater than or equal to 2, because that means there's at least 2, we want it to say yay. And if not, we want it to say boo. And so right now we see there are 2 ones. This cell says 2, and now we can see it says yay. All right. So we're going to need these formulas as we go into our assignment. Today for class example, we're going to be talking about Among Us. You and 4 other friends are playing Among Us. You feel like you're losing more than you should. You want to set up the probability to actually understand what's happening. Using some of the formulas we've learned about, let's set up some scenarios and get some odds for how likely you are to win. In this game of Among Us, there are 5 players and 1 imposter. And according to the Among Us Twitter, I looked this up, in a game of 5, crewmates have a 57.69% probability of losing. And so that means that 57.69% of the time, you'll lose, but you might win 42.31% of the time. And so let's set up the situations. Well, what are the different situations that could happen with the group of 5? If there's only 1 imposter, one in the first game, let's say the first person is the imposter and everyone else is a crewmate. In the second situation, the second player is. And what I want you to do is I would love for you to pause and take a moment to fill out row 3, 4, and 5. What are the 3 other situations that are possible? You did it, right? You paused? Yeah, you did? Okay, cool. So we're just going to enter in the rest of them. Again, now player 3 is the imposter. And then player 4 is the imposter. And in the last one, player 5 is the imposter, and everyone else is a crewmate. All right. So what we want to do next, just to kind of check for our sanity, the question says that only one imposter is here. And so we want to write in the imposters box equals count ifs, and we want to pick this range. And we want to say, well, if they're an imposter, we want it to count it. And so here, it has a suggested autofill, and that formula is actually going to work everywhere. So we could hit the suggested autofill. I'm going to hit the X, though. And I want us to practice this on the bottom right corner. We're just going to scroll down, and that formula will drag through. A quick check, there should be one imposter for each of these, and yep, each of these has one imposter. Great. Now, the probability. Here's the thing. What this means is, we just want to see what's the probability of you winning. And in order to do this, we want to have a random probability in place, because this will say, just say this is a game, what's the outcome going to be? We don't know. It could be one thing, it could be the other. So in order to do that, we're going to do equals rand, open close parentheses, because we want a probability between 0 and 1. All right, it's going to autofill again. We don't want that just yet, right? So we can drag that rand down, and we'll have it for these 5. And now we have these 5 different scenarios. And now the last thing we need to figure out is, are we going to win or are we going to lose? Well, we see here crewmates have a 57.69% probability of losing. So that means if we're over that number, we'll win. But if we're under that number, we're going to lose. So we need to say that this will equal if. If the probability in the cell to the left, so in this case, that's H28, and we can click on it. If H28 is greater than or equal to 0.5769, because that's our probability of losing, then we will win. So we can do a W. And if we don't, we're going to lose. So we'll put a no. Take a moment to try to fill in these boxes. What should go into these boxes? Boop, 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 boop. We paused again. Okay, we're going to keep going. Multiple ways you can do this. You could retype it, or you could drag it down, and it'll go into those boxes. And here we see right now, there's a 1 winning probability, and the other ones are losses. Eep. So right here, we want to see number of times you beat the imposter. So that means the number of times there's a W. So we're going to do equals count ifs, and we want this range. And we're going to choose the whole thing. We're going to go all the way down to the bottom here, because we want this formula to keep populating once we start putting more data. So count ifs, this is a W. We want to see how many times we win. How many times do we beat the imposter? All right. And you see, again, it changed because there's randomness here. And so now it's 3, and we can see there are 3 Ws. That's cool. What about the number of times you play? Well, the number of times you play, we just want to count how many rows there are that contain numbers. And we can use the imposters column for that. So equals count, and we want to count this column. And let's go all the way down, because we want to see, we want this to auto-populate over and over again. So equals, enter, okay? Great, shows me 5 numbers played. Oh, and now it's 5 wins. What's the probability of beating the imposter? That probability is going to be the number of times we beat the imposter divided by the number of times we played. So that's going to be B23 divided by B24. And right here I see in 5 chances, the time that I'm entering this in, with 5 games, we beat the imposter only 20% of the time. Our chances are 0.2. You can think of that, remember, we're moving the decimal place over by 2 when we're doing a probability. All right. What about for 10? I'm going to give you a moment to try to think. Can you quickly show how to do this for 10? I'll show you. One thing you could do. This thing right here is just going to keep repeating, right? Because that's the only 5 possibilities. So we can drag this down to 10. And you'll see it'll repeat all of those things. And then here, with these formulas, we can drag it down all the way. With this formula, it'll stay the same, so we'll drag it down all the way. And this formula, it'll stay the same, so we'll drag it down all the way. And you can see here up in the top left corner, our numbers have changed. The number of times we beat the imposter has changed. The number of total times we play has changed. And now it's at 60%. So in this case, we'll get 0.6. What about for 30? Take a moment. Pause. Did you pause? I think you just kept hit playing. Come on, pause, try it. Okay, now I trust you, you paused it. Okay, and again, we can do the same thing we did before. We can highlight over this, and we can drag this all the way down to 30. We can take this, and we can drag this down all the way to 30. We can take our formula here, our rand, and we can drag it down all the way to 30. This is just copying it into all those places. And the last thing we can do is drag this one down all the way to 30. And we'll see here in the end, at 30 points, we're going to have a 0.4 probability of winning. You can see that a lot of these numbers now are hovering 0.4, 0.6. That's getting closer to that 57.69 number we saw before. We're not going to win half the time, but this is showing us that there's more and more likelihood of us getting closer to that probability. But the thing I want to say is this: experimental probability is really cool because it shows us not what theoretically could happen, but what is actually happening, and how can we make predictions based on what we've already seen. Instead of having to play 30 games of Among Us in a row, we've now been able to calculate what are the possibilities of us winning or losing in these situations. You are going to now have an opportunity to try to do something similar to this for your exit ticket. In your exit ticket, though, you're playing in a game of 4 instead of a game of 5, but you're playing 100 different games. One thing to keep in mind is that in this case, the formula is a little different, because instead of a 57.69% chance of losing, you have a 52.55% chance of losing. And so you need to keep that in mind as you're making your formulas. Best of luck. Reach out to your pre-calculus teacher if you have any questions. That's me, Mr. Zamet, or Mr. Grossman. And let me know if you got this. Make sure you hit turn in on Google Classroom after you've completed this assignment. Best of luck.